Somewhere in the dark, 15 billion miles from the sun, a spacecraft older than most people alive is still whispering back to us. It was built before the first mobile phone call. Its computer holds less memory than a modern greeting card. And yet, every single day, it sends a signal across a distance so vast that the message itself, traveling at the speed of light, takes more than 22 hours to reach the Earth. That spacecraft is Voyager 1, and what it has been sending back in recent months has left the engineers at the Jet Propulsion Laboratory unusually quiet. Not panicked, not alarmed, quiet. Because the data arriving from beyond the edge of our solar system is doing something that the models did not predict. The space around Voyager 1, the space we thought we understood, is behaving in ways that suggest we have been wrong about something fundamental. Wrong about the shape of our cosmic neighborhood. Wrong about where it ends. Wrong, perhaps, about what waits just beyond. Tonight, we are going to follow that signal. We are going to travel with it, backward through the cold and the quiet, all the way to a small blue world where a group of people are still listening. And by the end, the sky above your window will feel a little different than it did before. If this is the kind of slow journey you enjoy, feel free to subscribe while you settle in. There is no hurry. There never is out here. Let us begin where Voyager began. Not in space, but in a desert. In the late 1970s, a rare alignment of the outer planets was approaching. Jupiter, Saturn, Uranus, and Neptune were about to arrange themselves in a gentle arc, a configuration that would not repeat for another 176 years. A small team of scientists realized that if a spacecraft launched at exactly the right moment, it could use the gravity of each planet to slingshot itself toward the next. One launch, 4 worlds. A grand tour of everything we had never seen up close. The mathematics of it was almost unreasonably beautiful. A single well-timed departure could, in theory, visit more of the solar system than every mission before it combined. But the window was narrow. Miss it, and the alignment would not return for generations. The engineers did not miss it. They built 2 spacecraft, in parallel, in a race against the geometry of the sky itself. 2 spacecraft were built. Voyager 2 launched first, on the 20th of August, 1977. Voyager 1 followed 16 days later, on the 5th of September. They were identical twins, each weighing just over 720 kilograms, each carrying a golden record etched with greetings in 55 languages, the sound of a mother kissing her child, the song of a humpback whale, and the location of the Earth marked out in pulsar coordinates in case anyone, anywhere, ever found them. The records were the idea of a small committee chaired by Carl Sagan. They gathered for about a year, arguing quietly about what, exactly, a civilization might want to say to strangers it would never meet. What music to include? What images? What pieces of ourselves would survive the long cold of interstellar space and still mean something on the other side? In the end, they chose 116 images, 90 minutes of music from across the cultures of Earth, the sounds of wind and thunder and a human heartbeat, and greetings in languages both living and long forgotten. Think for a moment about what that process must have felt like. A small group of people sitting in a room, trying to choose which human sounds best represent the whole of our kind. Imagine arguing about whether to include Mozart or Chuck Berry or a traditional Bulgarian folk song. Imagine the quiet seriousness of deciding which photograph should stand for a supermarket, which picture should stand for childbirth, Which image out of all possible images should represent a kiss? And knowing, as you chose, that whatever you put on that record would be the only version of these things the recipient, if there ever is one, would ever see. In the end, the choices were gentle. There is a picture of a sunset over an ocean, a picture of a woman holding a child, a picture of a page of music, a picture of the DNA structure, a picture of a man eating. None of these images are dramatic. None of them show war or violence or the worst things we have done. The committee considered including such things and decided, after long discussion, that if we were going to speak to the universe at all, we should speak gently and only of the things we loved. A small, edited portrait of us at our most hopeful, our best self, sent outward. The sounds on the record include a greeting from a young boy in English, saying only, "Hello from the children of planet Earth." The voice belongs to Nick Sagan, the son of Carl, who was 6 years old at the time. He is an adult now, of course, nearly as old as the Voyagers themselves. His small voice is out there, still moving outward, preserved on the record, unchanged by the decades that have passed for him since he recorded it. Somewhere in the galactic dark, a 6-year-old boy is still saying hello, and will continue to say it long after the boy who spoke the words has grown old and passed away. There is something almost unbearable about that if you let yourself sit with it. And yet, there is also something beautiful. A small fragment of tenderness, preserved perfectly, drifting onward. A greeting that will outlast its speaker by a vast margin. One of many small gifts we quietly placed inside the spacecraft, not knowing who, if anyone, would ever receive them. The engineers who built the spacecraft did not expect them to last. The original mission was planned for 5 years, just enough time to reach Jupiter and Saturn, send back photographs, and fall silent. Nobody designed these probes for the journey they are now making. Nobody built the components to survive nearly half a century in the radiation and cold of interstellar space. And yet, here we are, 48 years later, still receiving signals. Voyager 1 reached Jupiter in March of 1979. It photographed the Great Red Spot up close for the first time, revealing storms within storms, a hurricane larger than the Earth that had been spinning for at least 300 years. It discovered volcanoes on the moon Io, erupting sulfur into space, the first active volcanoes ever seen on another world. It saw the thin ring of Jupiter, delicate and almost invisible, a ring nobody had known existed. The photographs came down slowly, line by line, painted across the screens of the mission control room in Pasadena over the course of hours. Scientists gathered in the hallways to watch. When the image of Io appeared, with its yellow sulfur plumes rising into space, several people are said to have simply stopped speaking for a long moment. A moon smaller than our own, alive with volcanism, in a place they had expected to find only frozen rock. In the weeks that followed, the Voyager cameras showed them more things that had never been seen. Europa, another of Jupiter's moons, turned out to have a surface of smooth, cracked ice, like a frozen ocean whose crust had been split and resealed many times. Ganymede was streaked with ancient grooves, a record of geological activity older than anything on the Earth. Callisto was pitted with craters so numerous they overlapped, a surface that had not changed for billions of years. Each moon was its own world. Each was different from every other, and each, until Voyager arrived, had been a blur of light to us, an object known only by its orbit and its approximate size. There is a particular kind of silence that falls on a room full of scientists when a long-awaited image resolves on a screen. It is not the silence of disappointment. It is the silence of adjustment. the silence of minds quietly reshaping themselves to accommodate new information. This silence fell several times during the Voyager 1 encounter with Jupiter, and it would fall again later when the spacecraft reached Saturn, and again, later still, in the decades that followed, as the probe kept sending back news from regions that no one had ever expected a small machine built in the 1970s to reach. Then Voyager 1 swung onward to Saturn. In November of 1980, it arrived at the ringed planet and performed a maneuver that would change its fate forever. Mission controllers chose to route it close to Titan, Saturn's largest moon, because Titan had an atmosphere, and atmospheres are rare. The flyby was scientifically priceless, but it came at a cost. The gravity of Titan bent Voyager 1's trajectory upward, out of the plane of the solar system, tilting it northward at an angle of about 35 degrees. The decision to prioritize Titan was, in some ways, a choice about meaning. The engineers knew exactly what it would cost. They knew that routing the spacecraft close to that single moon would send it away from everything else. No Uranus, no Neptune, no chance ever of another planetary encounter. Voyager 2, still flying behind, would carry on to visit the ice giants. But Voyager 1 would, from that moment, be purely outbound. A diplomat, finished with its visits, turning its face toward the dark. The reasoning was that Titan was simply too interesting to miss. A moon with a dense atmosphere, thicker even than Earth's, wrapped in a haze so opaque that no telescope had ever seen its surface. To fly close and measure that atmosphere, to pass through its outer layers and taste its chemistry, was an opportunity that would not come again for decades. They chose it. They chose Titan. They let the rest go. When the flyby happened, the images showed only a smooth orange sphere, featureless and still. The haze was too thick to see through with Voyager's cameras. The surface of Titan would not be revealed for another 25 years, when the Huygens probe, carried by the Cassini mission, would finally descend through those clouds and land, softly, on a beach made of water ice and hydrocarbon sand. By that time, Voyager 1 was already approaching the edge of the heliosphere, its contribution to the story of Titan finished, its attention elsewhere. From that moment on, Voyager 1 was no longer on a tour. It was on a departure. It would never see another planet, ever. Its path now pointed toward nothing in particular, just the slow, cold darkness between the stars. And for the next 3 decades, it simply flew. Past the orbit of Uranus without seeing it. Past the orbit of Neptune without seeing it. Past Pluto unseen. Past the edges of what any human-made object had ever reached. Those decades between Saturn and the edge of the solar system were long and mostly quiet. The spacecraft was healthy. Its instruments continued to record the thinning plasma of the outer solar wind. Its trajectory took it on a long, slow diagonal, tilted out of the plane where most of the solar system lives. There were no planets nearby. There were no moons. There was, for years at a time, essentially nothing to see, only a steady background of particles and magnetic fields to measure, only the thin whisper of data to send home. The engineers adjusted. They turned off systems that were no longer needed. They planned for the long journey ahead. They settled into a routine of listening, of small daily check-ins, of the careful discipline of caring for a spacecraft whose most dramatic moments were probably already behind it. The mission became, for a while, a kind of meditation. Long stretches of calm, punctuated only by the occasional anomaly, the occasional command, the occasional small repair. And Voyager flew on, quietly, for year after year. In 1990, from a distance of about 6 billion kilometers, it turned its camera around one last time at the request of Carl Sagan and took a photograph of the Earth. In that image, our entire world, everything that has ever happened, every war, every love, every sunrise witnessed by any living thing, appeared as a single pale blue dot, less than 1 pixel across, suspended in a beam of scattered sunlight. Sagan had pushed for the photograph for years. Many engineers at the laboratory had resisted. The camera was fragile. Pointing it back toward the sun was risky. And the scientific value of the image, in strictly technical terms, was close to zero. It would not teach us anything new about the Earth. It would not reveal any new physics. It would, at best, produce a small, almost empty frame with a pixel or two of blue lost in the glare. Sagan argued anyway. He argued that the image was not a scientific image, it was a human one. He argued that there was value, a certain kind of irreducible value, in showing our home from as far away as we could manage, in letting us see ourselves from a place where we looked like almost nothing. In the end, the argument won. The command was sent, the camera turned, the shutter opened, and the photograph came back. When Sagan saw it, he wrote a short passage of reflection that has since become one of the most widely shared pieces of prose in the history of science writing. He did not exaggerate what the image showed. He simply described it. A mote of dust, a pale blue dot, home. Every person you have ever loved, every person who has ever been, all of them on that one point of light. All of our history, all of our quarrels, all of our triumphs and losses, compressed into a single pixel hanging in the darkness. Then the camera was shut off forever to save power. And Voyager 1 kept going. Now here is where the story begins to deepen, because somewhere between the orbit of Neptune and the empty darkness beyond, there is a boundary, a shape, a thing our sun carves out of the galaxy itself. It is called the heliosphere. Imagine for a moment that the sun is breathing, not light, but particles, a constant wind of charged plasma streaming outward in every direction at speeds of over 1,000,000 miles per hour. This solar wind fills the space around our sun, pushing outward, holding back the colder, thinner wind of the galaxy beyond. Where those two winds meet, they form a boundary, a kind of enormous bubble with the sun at its center and all the planets floating safely inside. The bubble is not a small thing. It extends far beyond the outer planets, beyond Pluto, beyond the Kuiper Belt, beyond the regions where comets are born. On one side, where the sun plows into the galactic wind, the bubble is compressed, rounded, a little like the front of a ship. On the other side, behind us, it trails away into what scientists used to think was a long, comet-like tail. We now suspect, based on the Voyager data, that this tail may not exist in the form we imagined. The shape of our protection, it turns out, is still being drawn. But whatever its exact form, the bubble is real. It is a physical thing. And it shields everything inside it, including the Earth, including us, from a significant fraction of the high-energy particles that travel through the galaxy. Without the heliosphere, our planet would be exposed to more cosmic radiation than it currently is. The atmosphere provides another layer of protection, of course, and the Earth's magnetic field another. But the heliosphere is the first and outermost of those shields. It is the gentle outer wall of the place we live.
and we did not know it existed until a few decades ago. That bubble is the heliosphere.
And for most of human history, we had no idea it existed. We knew the sun gave off heat. We knew it gave off light. But the notion that it also exhaled a continuous ocean of particles, shaping a region of space larger than anything we can easily picture, was not confirmed until we had the tools to go and measure it. Voyager 1 was one of those tools. The first, in fact, to ever reach the edge. The boundary of the heliosphere has several layers. The innermost is called the termination shock, where the solar wind suddenly slows from supersonic speeds down to something quieter. Beyond that lies the heliosheath, a turbulent zone where the solar wind piles up against the pressure of interstellar space. And beyond that is the heliopause, the final frontier, the place where the sun's influence ends and the galaxy begins. Voyager 1 crossed the termination shock in December of 2004. It entered a region nobody had ever measured directly. The plasma instruments recorded wild fluctuations, magnetic fields twisting in patterns that models had not predicted, particles behaving in ways that surprised everyone. Then, for nearly a decade, it swam through the heliosheath. Scientists waited. Year after year, they watched the numbers change, watched the solar particles thin, watched the galactic particles grow stronger. They were waiting for a specific moment, a moment when the data would tell them unambiguously that Voyager 1 had left. That moment came on the 25th of August, 2012. On that day, the count of solar particles around the spacecraft dropped sharply, and the count of galactic cosmic rays rose to a new, steady level. The magnetic field changed direction. Voyager 1 had crossed the heliopause. It was the first human-made object ever to enter interstellar space. The team at the Jet Propulsion Laboratory did not celebrate immediately. That is not how this kind of discovery works. The data had to be verified. The patterns had to be confirmed across multiple instruments. Other explanations had to be ruled out. There is, in science, a reflex of caution that precedes every announcement of something new, especially something as historic as crossing into interstellar space. The scientists studied the numbers for months. They asked each other hard questions. They checked and rechecked. Only then, carefully, did they begin to say it out loud. Voyager had crossed over. Voyager was outside. For the first time in the entire 4.5 billion-year history of the solar system, something built by a creature born on the Earth had left the bubble of our sun. It is worth pausing on the scale of that statement. Not the scale in kilometers, though those are staggering. The scale in evolutionary terms. From single-celled life to the first animals, from animals to hominids, from hominids to language, from language to writing, from writing to physics, from physics to rocketry, from rocketry to a small nuclear-powered probe passing through the final wall of the sun's influence. All of that took somewhere between 3 and 4 billion years of continuous development on a small rocky world in one arm of one galaxy. And the result, the culmination of all of that, was a small box of electronics, weighing less than a large dog, sending home a single, careful data set that said, "I have crossed." The announcement, when it came the following year, was careful, cautious. Scientists do not like to overstate, but the implication was enormous. For the first time in the history of our species, we had a probe outside the bubble of our own sun, a probe measuring the raw, unfiltered medium of the galaxy itself. And that is when things began to get strange. Because interstellar space was supposed to be quieter, emptier, a place where the galactic magnetic field ran in smooth, predictable lines, and the particle densities behaved according to well-understood physics. Instead, Voyager 1 began to report something else. The magnetic field outside the heliopause was not aligned the way models had said it would be. It was oriented almost exactly the same as the field inside the bubble, as if the boundary did not really exist in the way we had drawn it on all those textbook diagrams. Then, in 2020, Voyager 1 detected a persistent hum, not a signal, not a transmission, a faint, continuous vibration in the plasma around the spacecraft, a low-frequency oscillation that had no clear source. The instruments had been tuned to catch bursts of plasma waves triggered by solar events, sudden flares of energy that rippled outward from the sun and reached the probe years later. But this was different. This was always there. A steady drone in the medium of the galaxy itself. Scientists called it the interstellar plasma hum. Imagine standing in a room that you thought was silent. Then, slowly, you realize there is a sound beneath the silence. A thin, almost inaudible tone that has been there the whole time, that fills the room and everything in it. That is what Voyager 1 heard. The galaxy, it turns out, is not silent. It is humming, softly, endlessly. A note so quiet that you need to be 15 billion miles from any star to notice it. Researchers, when they convert the data from the plasma wave instrument into audio form, describe the sound as almost musical. A steady, high tone, shifting slightly in pitch over time, as if the spacecraft were passing through layers of slightly different material. When played back in a lecture hall, the sound produces a strange effect on audiences. People fall silent. People lean forward. There is nothing dramatic in it, no melody, no rhythm, only a thin, unwavering tone coming from the space between the stars. And yet, when the lights dim and the recording plays, something in the room shifts. It is the sound of interstellar space, represented in a form our ears can understand. It is the sound of a place that no human has ever been, and where no human will ever go, at least not in our lifetimes, and perhaps not in any lifetime we can presently imagine. It is a sound that was not meant to be heard, a sound that existed for billions of years before we arrived, and will continue for billions of years after we are gone. To have listened to it, even briefly, even as a digital approximation, is already a small privilege. And that, remarkably, was only the beginning. There is something worth sitting with for a moment before we go on. The hum that Voyager 1 detected is not the sound of anything dramatic. It is not the echo of a supernova or the pulse of a distant black hole. It is simply the ambient vibration of the galaxy at rest, the background note of the Milky Way itself, playing quietly in the space between the stars. And we would never have known it was there had we not left the bubble. Think about what that means for a little while. For all of human history, every measurement we ever made, every sound we ever recorded from space, was taken from inside our sun's protective shell. We thought we were listening to the universe, but we were listening to the universe as filtered through our own star. The hum, the real voice of the galaxy, had been drowned out the entire time by the wind of the sun. It took a spacecraft older than most of the scientists now studying it to slip far enough away to hear the quiet. And once the quiet was heard, new questions began to form. Because if we had been wrong about the silence, what else had we been wrong about? By 2022, Voyager 1 was more than 23 billion kilometers from Earth. The signals it sent took about 21 hours to arrive. The spacecraft was cold, its plutonium power source slowly fading, producing a little less electricity each year than the year before. Engineers had already shut down several instruments to conserve power. The cameras had been off for decades. The heaters were being rotated carefully, one system at a time, warmed enough to function, the others left to drift near the temperature of deep space. And then, In May of 2022, something happened that nobody could explain. The attitude control system on Voyager 1 began sending back data that made no sense. The system was responsible for keeping the spacecraft's antenna pointed at Earth. Without it, we would lose contact forever. And the readings it was transmitting suggested that the system was working perfectly, that the antenna was aimed correctly, that everything was fine. But the telemetry itself was corrupted, scrambled, as if the numbers were being pulled from random locations in the computer's memory and stitched together into a message that looked almost right, but meant nothing. The team at the Jet Propulsion Laboratory studied the problem for months. They could not understand it. The spacecraft was still flying, still functional, still pointed at Earth. But the part of it that was supposed to confirm these things was producing noise instead of data. They waited. They tested. They rewrote old code that had not been touched since before many of them were born, working from manuals written on paper in the 1970s, consulting retired engineers who had come back out of curiosity to help. Slowly, painstakingly, they diagnosed the problem. A small piece of memory inside one of Voyager's computers had failed. Just a few bits. Just enough to scramble one routine. They found a workaround. They patched the software from 15 billion miles away. And the spacecraft, in November of 2023, started sending clean data again. It was a small miracle, a small act of tenderness, repairing something so far away that the repair itself took nearly 2 full days of light travel to confirm. And it was, in a way, a glimpse of the relationship we now have with this machine. It is old. It is failing. We are not going to save it forever. But for as long as it keeps speaking, we will keep listening. And what it has been telling us in these recent transmissions is that the edge of our solar system is not what we thought it was. The traditional picture of the heliosphere, the one you might have seen in a textbook, shows a neat teardrop shape, a rounded front where the sun plows into the galactic wind, and a long tail stretching out behind, like the wake of a boat. This shape has been drawn and redrawn for decades. It appears in museum exhibits, in educational videos, in the minds of anyone who has thought about where the solar system ends. But the data from Voyager 1, combined with data from its twin Voyager 2, which crossed the heliopause later, in November of 2018, suggests that the real shape is different. Less like a teardrop, more like a croissant, or a deflated beach ball, or something asymmetric and strange, with lobes and bulges that models have only recently begun to include. Some scientists now think the heliosphere may not have a long tail at all, that instead of streaming out behind us as we move through the galaxy, the bubble simply rounds itself off, tucked neatly into a shape closer to a sphere than a comet. Others disagree. The debate is active. The data is incomplete. And the only 2 spacecraft that have ever directly measured the boundary are both slowly running out of power. There is a kind of poetry in that. We finally built something that could answer the question, and it is answering it slowly, incompletely, and with a fading voice. Every piece of information Voyager 1 sends back now is precious. Every kilobyte costs years of patience. Every measurement is one of the last measurements we will ever have of this region, perhaps for a very long time. The next probe capable of reaching interstellar space has not yet been built. The funding has not been approved. The technology, strangely, has not advanced as much in this one narrow domain as you might think. Voyager's nuclear power source, its ability to communicate across such vast distances, the simple ruggedness of its design, these are all things we would have to relearn how to build. So for now, we have Voyager 1. Alone out there,
whispering. And something else has been emerging in the data, something that is harder to put into words. The density of charged particles around Voyager 1 has been slowly increasing. Not dramatically, just a steady, gentle rise, year after year. At first, scientists thought this was a temporary effect, a transient feature of the local interstellar medium, the patch of galactic space the spacecraft happens to be flying through. But the rise has continued, and continued. And as the data has accumulated, a quieter explanation has begun to take shape. The idea is that Voyager 1 may be approaching a new boundary. Not the end of the heliosphere, that is behind us now, but something ahead, a region where the interstellar medium itself changes character. A region that may be the beginning of the larger bubble that surrounds not just our solar system, but an entire cluster of nearby stars. A bubble carved into the galaxy millions of years ago by ancient supernovae. A hollow place in space where the density is low, where the temperature is high, where the remains of exploded stars have swept the gas thin. This bubble has a name. It is called the local bubble. And our entire solar system is drifting through its interior, slowly, like a small boat in a vast, nearly empty sea. The local bubble is believed to have been carved into the surrounding interstellar medium by a series of supernovae that occurred roughly 14 million years ago. A cluster of massive stars, not far from where the solar system now drifts, exploded one after another over a span of a few million years, sweeping the gas outward in a slow, expanding shell.
The result is a region of space about 1,000 light years across, where the density of interstellar matter is unusually low, and where the temperature, paradoxically, is unusually high, the lingering echo of all that ancient heat. Our solar system entered the local bubble a few million years ago, drifting in from the outside. We are now well within it, near its middle, and we will continue to drift through it for a few million more years before we eventually emerge out the other side into whatever waits beyond. None of this happens on a timescale that any human will experience, but it is happening. It has been happening for longer than our species has existed, and it will continue long after the last trace of our civilization has returned to dust. Voyager 1, by reaching the edge of the heliosphere, has given us our first direct taste of the environment inside the local bubble. The plasma density measurements, the magnetic field readings, the cosmic ray counts, all of these are teaching us what it is actually like out there, in the thin, warm gas left behind by those ancient supernovae. We are, through Voyager, getting our first real glimpse of the neighborhood our planet has been living in all along. If Voyager 1 is indeed approaching the wall of the local bubble, we do not know what it will find there. We do not know how sharp the transition will be, or how the instruments will respond, or whether the spacecraft will still be alive when it arrives. The wall, if it exists, may be hundreds or thousands of years of travel away at Voyager's current speed. Voyager will be long silent by then, a cold, dark body drifting through a region it can no longer describe. But the fact that we can even imagine such a journey, the fact that we have a probe whose path is now defined not by the gravity of planets, but by the geography of interstellar clouds, is itself a kind of quiet astonishment. Let us slow down for a moment and let that settle.
Voyager 1, right now, as you are listening to this, is moving at about 17 kilometers per second relative to the Sun. That is roughly 61,000 kilometers per hour. It is one of the fastest objects ever launched by humanity. And even at that speed, it will take approximately 40,000 years to come within 1.5 light years of another star. That star is called Gliese 445, a small red dwarf that currently sits about 17 light years away. Voyager is not aimed at it. The encounter will be a passing, not an arrival. 40,000 years from now, when that quiet flyby occurs, there will be no one on Earth who remembers the names of the people who built the spacecraft. The language they spoke may no longer be spoken. The continents will have shifted slightly. The species that launched Voyager may no longer exist in the form it does today. And still, Voyager will be moving, carrying its golden record, carrying the sound of a kiss, a whale song, a greeting in Akkadian, an image of a child, carrying our location etched in the geometry of 14 pulsars, a kind of cosmic return address that will remain readable for tens of thousands of years after we ourselves may be gone. The pulsar map, for those who have never examined it carefully, is a small diagram etched into the cover of the golden record. It shows the Earth at the center, with lines radiating outward to 14 known pulsars, each pulsar labeled with the unique rhythm of its rotation. Pulsars are rapidly spinning neutron stars, and each one pulses at a specific, stable frequency, like a natural lighthouse turning in the dark. If you know the frequencies of those 14 pulsars, and if you know their positions relative to each other, you can triangulate exactly where the Earth was at the moment the record was made. The map is, in other words, a set of coordinates written in a language that relies only on physics.
Any civilization capable of building interstellar receivers should, in principle, be able to read it. And the precision of the coordinates, tied to the known rotation rates of the pulsars, encodes something even more remarkable. Pulsars slow down gradually over time, at predictable rates. If someone finds the golden record 1,000,000 years from now, and reads the pulsar frequencies etched on its cover, they will be able to figure out not only where we were, but when. The map is also a clock, a message sealed with a timestamp that will remain readable across enormous spans of time. There is, in this, a kind of quiet arrogance, and also a kind of quiet hope. We sent the record knowing, probably, that no one would ever find it. The odds of a random spacecraft being encountered in the vastness of interstellar space are vanishingly small. Voyager will likely drift for billions of years, undetected, unread. But we included the coordinates anyway. We included the timestamp anyway. We made sure that, in the almost impossible event that someone ever did find it, they would know where we had lived and when. That small gesture, made by a committee of people in the 1970s, has now been unfolding for 48 years. It will continue unfolding for a very, very long time. There is something both humbling and comforting in this. To know that a small part of us has been sent outward, not as a weapon, not as a colonizer, but simply as a message, is to feel something shift in the way you think about your own life. The spacecraft was built by people who knew they would never see its final fate. They did their work carefully, lovingly, and then they let it go. They entrusted it to time. And time, as it turns out, has been kind. Let us pause here and imagine the room where the signals still arrive. There is a facility called the Deep Space Network, a trio of enormous radio antenna complexes spread around the world, in California, in Spain, and in Australia. They are positioned roughly 120 degrees apart, so that as the Earth turns, at least one of them is always pointed outward, into the dark, listening. They track dozens of spacecraft, but Voyager 1 is, in some quiet sense, the oldest customer, the most distant, the one whose signal, when it comes in, takes more care to hear than almost anything else. The complex in California sits in a valley not far from the town of Goldstone, in a stretch of desert where the skies are mostly clear and the background radio noise is low. The complex in Spain, near the town of Robledo de Chavela, operates out of a set of low white buildings surrounded by pine forest. The complex in Australia, near Canberra, sits in a similar landscape, wide and quiet. All three complexes are deliberately chosen to be far from cities, far from radio interference, in the kind of places where the only thing above you is the open sky and the thin, persistent hiss of the universe. The antennas themselves are vast. Some of them are 70 meters across, larger than a basketball court, capable of swinging silently to follow a target across the sky. Inside the control rooms, technicians watch screens filled with numbers that most of us would not know how to read. The signal from Voyager, when it is received, is so faint that it has to be separated from the natural radio noise of the universe itself, extracted grain by grain from the background hiss of the cosmos. When that signal is successfully locked, a small indicator on one of the screens goes green. And somewhere, a technician nods. Another day, another contact, another reminder that the old spacecraft is still out there, still flying, still choosing, for reasons we can only describe as fortunate, to keep speaking. It is easy to forget, in the rush of our own lives, that this is happening constantly in the background of the world. While you work, while you eat, while you lie awake in the small hours, a thin thread of radio energy is reaching Earth from deeper in space than any human has ever been. It is doing so right now. It has been doing so every day of your life. There is a certain comfort in knowing that, regardless of whatever is happening in your own small corner of the world, somewhere there are antennas pointed outward, and somewhere technicians are still watching screens, and somewhere the data from Voyager is still being written into the long record of what humanity knows. The mission does not stop for anything. It does not stop for weekends. It does not stop for wars. It does not stop for the small private heartbreaks that fill so much of ordinary human life. The listening simply continues, patient and quiet, night after night after night. The antennas themselves are vast. Some of them are 70 meters across, larger than a basketball court, capable of swinging silently to follow a target across the sky. Inside the control rooms, technicians watch screens filled with numbers that most of us would not know how to read. The signal from Voyager, when it is received, is so faint that it has to be separated from the natural radio noise of the universe itself, extracted grain by grain from the background hiss of the cosmos. When that signal is successfully locked, a small indicator on one of the screens goes green, and somewhere a technician nods. Another day, another contact, another reminder that the old spacecraft is still out there, still flying, still choosing, for reasons we can only describe as fortunate, to keep speaking. It is easy to forget, in the rush of our own lives, that this is happening constantly in the background of the world. While you work, while you eat, while you lie awake in the small hours, a thin thread of radio energy is reaching Earth from deeper in space than any human has ever been. It is doing so right now. It has been doing so every day of your life. And here is perhaps the strangest thing of all. The Voyager probes were not the first objects humanity sent into deep space, but they are almost certainly the last ones of their particular kind. The generation of engineers and scientists who designed them grew up in a world where missions to the outer planets were new, where the technology was invented almost fresh for each attempt. They were willing to accept enormous risk in exchange for enormous reward. They built spacecraft that were simple, robust, and patient. They did not know how to build anything else. That culture has, in many ways, faded. The Voyager program was a product of a specific moment, a specific confluence of political will and scientific optimism and engineering boldness. And moments like that are rare. Nothing quite like Voyager has been launched since. Other probes have gone to the outer planets, yes, and one of them, New Horizons, has passed Pluto and is now on its own slow way out of the solar system. But no probe has been built with the explicit goal of crossing the heliopause and reporting back from the other side. Voyager is still the only witness we have, which makes its quiet persistence all the more remarkable. There are, in this story, several moments that scientists describe as almost eerie. One of them is the behavior of the cosmic ray counts as Voyager 1 approached the heliopause. For months leading up to the crossing, the counts had been rising and falling in ways that nobody could quite interpret. Some scientists thought the boundary was approaching, others thought it was still far away. The data was mixed. The arguments were patient and careful and unresolved. Then, in a single day, everything changed. The solar particles dropped, the cosmic rays rose, the magnetic field turned, and Voyager 1 was outside. The boundary, when it came, was not a slow transition. It was a threshold. As if the spacecraft had stepped through a doorway into a different kind of space, and the doorway had closed quietly behind it. Scientists had expected something gradual. What they got was a wall. A thin one by cosmic standards, but a wall nonetheless. A surface in space where the sun's reach simply ended and the galaxy began. This was surprising, and more importantly, it raised questions that we still cannot answer. How is the boundary maintained? What forces hold it in place? How does the galactic magnetic field, which should be pressing in from all sides, interact with the sun's field to produce such a sharp edge? These are questions that the instruments on Voyager 1 are uniquely qualified to probe, and that we have only a little time left to ask. There is a concept in philosophy called the sublime, a kind of awe that arises when we encounter something too vast or strange to comprehend in a single thought. Voyager's journey produces something like that, quietly, in anyone who sits with it for long. Not fear, exactly, not wonder, exactly, something softer, a kind of slow recognition that the universe is larger than we normally let ourselves imagine, and that a small part of us has been sent out into it, carrying a gentle message of presence, and that this part of us is still moving, still reporting, still ours in some attenuated but real way. When you think about it like that, Voyager stops being a machine and becomes something more like a question. A question we asked in the 1970s, and whose answer is still being returned, very slowly, across a distance that the human mind cannot hold all at once. The answer is not arriving all at once either. It is arriving in fragments, particle counts, magnetic field orientations, plasma density measurements, the thin, constant hum of the interstellar medium. Each fragment is a small piece of a larger picture that we are assembling, year by year, through the patient work of listening. And the picture that is emerging is one we were not entirely prepared for. The shape of the bubble is stranger than we thought. The boundary is sharper than we thought. The medium beyond is humming in ways we had not expected. The density is rising in ways that suggest new structures lie ahead. Each of these findings, on its own, is modest. But together, they form a portrait of a solar system that is more complicated, more layered, more alive with invisible processes than almost any model had predicted. And the instrument that is telling us all of this is nearly out of power. There is a room at the Jet Propulsion Laboratory where the signals from Voyager 1 come in. It is not a dramatic room. There are no blinking lights in elaborate patterns, no large screens with swirling graphics. Mostly, there are computers, quiet ones, and a small group of people, many of them older now, who have spent a significant portion of their professional lives listening to a single, steady voice from very far away. When the data arrives, it arrives slowly. The radio signal from Voyager 1, by the time it reaches the Deep Space Network antennas on Earth, is unimaginably faint. The power of the transmission, when it leaves the spacecraft, is about 22 watts, roughly the same as the bulb in a refrigerator. By the time that signal has traveled 15 billion miles, it is spread so thin that the energy collected by the giant 70-meter dishes on Earth is measured in units so small they barely seem to exist. We are catching a whisper thinner than a breath, and we are catching it on purpose, with instruments sensitive enough to register the difference. And still, the data comes through. Numbers, magnetic field readings, particle counts, the gentle hum of the interstellar medium. Day after day, year after year. The people in that room know what is coming. They have known for a long time. Voyager 1's plutonium power source is decaying at a predictable rate. Each year, it produces about 4 watts less electricity than the year before. Already, several instruments have been turned off. Soon, more will follow. The heaters will go first, probably, or the last of the science instruments, one by one, a slow dimming rather than a sudden end. Current projections suggest that sometime in the mid to late 2030s, the spacecraft will no longer have enough power to send any signal at all. After that, Voyager 1 will still exist. It will still be flying. It will still be carrying its golden record into the dark. But it will have gone silent, and the last thin thread connecting us to it will have been cut. This is not a tragedy exactly. It is more like a long, quiet goodbye, one that has been happening in slow motion for many years, and will continue to happen for many more. The engineers who work on Voyager speak about this with a kind of tenderness. They do not rush. They do not panic. When a component fails, they work carefully to find a workaround, knowing that each fix might be the last. When the signal comes in cleanly, they take a small, private pleasure in it. The spacecraft is older than many of them. It was there before they started. It will, in some sense, outlive them, drifting on long after the last signal fades. And it is worth thinking, for a moment, about what this means on the human scale. There are very few projects we undertake as a species that are designed to last longer than a single lifetime. Cathedrals, perhaps, certain bridges, a handful of scientific experiments. Most of what we build is temporary, serving the present, measured in years or decades. Voyager is different. Voyager was launched by people who knew it would outlive them, who understood that the answers it sent back would be interpreted by others, by strangers, by generations of scientists not yet born when the spacecraft left the launch pad. They built it anyway. They built it carefully. They made it beautiful. And then they watched it go. There is a kind of faith in that. Not religious faith necessarily, though it could be, but a faith in the value of continuation, a faith that the next generation will care enough to keep listening, that the children of the people who launched Voyager will still want to know what it has to say. So far, that faith has been rewarded. The mission continues. The people have changed, but the listening has not. Consider for a moment the particular sort of patience that this mission requires. When you send a command to Voyager 1 today, the command travels outward at the speed of light for roughly 22 hours before it reaches the spacecraft. Voyager then executes the command, and its response travels back for another 22 hours. A single question and answer can take most of 2 days. There is no way to hurry this. The speed of light is the speed of light. It is simply how fast the universe permits information to travel. The engineers have learned to think in these timescales. They send commands and wait. They plan experiments that will complete over weeks, not minutes. They accept that the spacecraft is, in a sense, always in the past from our perspective. That everything we learn about it is already 44 hours old by the time we learn it. If Voyager fell silent right now, we would not know for almost a full day. And by the time we knew, the silence would be older than our knowledge of it. There is something both strange and soothing in that delay. It slows everything down. It forces the humans on the receiving end into a kind of quiet discipline. You cannot rush interstellar space. You can only wait and listen and trust that the signal will come. This patience has, over the years, seeped into the culture of the mission itself. The people who work on Voyager do not tend to be hurried people. They move through their days with a certain deliberate calm. They speak carefully. They write carefully. They are used to sending a command and then waiting almost 2 days to see if it worked. They are used to the spacecraft being, in effect, always in a slightly earlier version of the present than they are. And over time, this has shaped them. You cannot work on a mission like this for 30 years without absorbing some of its temperament. Perhaps that is one of the quieter gifts Voyager has given us. Not just the scientific data, which is substantial, but the example of a different relationship with time. A relationship in which nothing can be hurried, in which every exchange is slow, in which the act of listening is more important than the act of speaking. We live, in most other domains, in a world that rewards speed. Instant messages, fast trades, rapid decisions. Voyager moves at a different tempo. Voyager reminds us that there is another way to be in time, and that it is not worse, just different. If you sit with that long enough, it begins to feel like a small form of medicine, a gentle corrective to the pace of our days, a reminder that out there, something of ours is moving slowly, waiting patiently, speaking softly, and that somewhere, in a quiet room, someone is waiting patiently to hear it. And out there, in the quiet, Voyager keeps moving. It is moving now as you listen to this. It is moving through a region of interstellar space that no human eye will ever see, through a darkness so complete that the concept of darkness almost ceases to apply, because there is nothing to be dark against. The stars are distant points of light, the same as they appear from Earth, only perhaps a little clearer, without an atmosphere to blur them. The sun, from Voyager's vantage, is now just a particularly bright star. Not a disk anymore, not a source of warmth, just a pinprick among many, indistinguishable at a glance from the others. Imagine turning around and looking back from there. Imagine, if a camera were still working, what the view would be.
a black sky,
a scattering of stars, and somewhere among them, a yellow one, slightly brighter than the rest, around which a thin circle of debris and dust orbits, invisible at this distance. Inside that invisible circle is everything we have ever known, every human being who has ever lived, every memory, every song, every quiet evening like this one, and it all fits into a single pinprick of light. The philosopher might say this is humbling. The astronomer might say this is clarifying. The poet might simply say it is true. That the scale of the universe, when you really attempt to hold it in your mind, does not diminish what happens here. It makes it rarer, more improbable, more precious. The fact that anything is happening at all on that small blue dot is a small statistical miracle. And the fact that some of what happens includes listening to the edge of the solar system, including building a machine to send a message outward, including caring what the machine finds, is perhaps the most miraculous thing of all. Think of all the small, ordinary things that happen every day on that pinprick of light. Someone pours a cup of tea. Someone writes a letter they will never send. Someone sits by a window and watches the rain. All of these things, all of this texture, all of this ordinary human life is unfolding on a tiny sphere in one small corner of one galaxy among hundreds of billions. And yet from it, we reach outward. We build machines. We send them away. We listen carefully for what they tell us back. Voyager 1, in the end, is less a spacecraft than a slow thought. A thought that began in the 1970s, in the minds of engineers and scientists who wondered what was out there. A thought that has been extending outward in the form of a small, cold machine ever since. A thought that has now reached beyond the shell of our sun and is beginning to brush against the wider galaxy. The thought is not finished. It may never be finished. It may continue long after we ourselves have stopped thinking. A kind of inheritance we have already given away, whose unfolding we will not be here to witness. There is an old idea, found in many cultures, that the measure of a civilization is what it builds that outlasts itself. Roads, libraries, quiet works of art, things made carefully with the knowledge that their usefulness will extend beyond the lifetime of any single maker. By that standard, the Voyagers are among our most characteristic gifts to the future, not because they are the largest or the loudest, but because they were built with an unusual combination of humility and ambition. Humility enough to admit that we might never know who, if anyone, would find them. Ambition enough to make them anyway. To send them outward, signed with our names, in the hope that something of us would persist. There is a generation now growing up that will barely remember a time before the Voyagers left the solar system. For them, the spacecraft will have always been in interstellar space. The crossing of the heliopause will be a historical fact, already settled, already part of the background of what humanity has done. Their children, in turn, may grow up in a world where Voyager has gone silent, where the last signal has already been received, archived, filed away. The spacecraft, for them, will be a thing that used to speak, a thing that now simply drifts. Their children's children may not think of Voyager at all. And yet the spacecraft will still be out there, still moving, still carrying the small cargo we entrusted to it. The memory of Voyager may fade within a few generations, on our side, but the spacecraft itself will persist, unbothered by whether we remember it or not, carrying our greeting onward through the dark.
There is a kind of release in that thought, a recognition that some of the most meaningful things we do are not the things that will be remembered.
They are the things that quietly continue, whether remembered or not.
The things that slip beyond us, that stop being ours, that become simply part of the universe. Voyager is, or is becoming, one of those things. A small, quiet presence, no longer fully ours, no longer fully anyone's, just a little machine drifting through the long quiet of the galaxy, with our old signatures still etched on its side. There is a comfort in that, if you are willing to feel it. The comfort is not the comfort of certainty. It is not the comfort of a story with a clear ending. It is the quieter comfort of being part of something ongoing, of knowing that your species, for all its flaws, has also built beautiful, patient machines and sent them into the dark, not to conquer anything, but simply to know, to listen, to bring back the hum of the galaxy and lay it gently in our ears. Picture for a moment the long future of the spacecraft. Long after the last signal fades, long after the plutonium inside it has decayed to near nothing, long after every circuit inside has cooled to the temperature of the surrounding void, Voyager 1 will continue on its path. The shape of that path, projected forward, is already well understood. It will not return. It will not be caught by any star. It will drift outward, slowly, along a trajectory that will carry it above the plane of the galaxy, and then, very gradually, into the wider darkness between the spiral arms. In about 40,000 years, it will make its closest approach to the red dwarf Gliese 445. That star will be, at the time, about 1.5 light years away from the spacecraft, a distance that is, by human standards, still unimaginably large, but by the standards of interstellar space, almost a kiss. Voyager will pass, silently, and continue. The star will not notice. The spacecraft will not stop. Long after that, Voyager 1 will continue to drift, potentially for billions of years.
The galactic environment is not entirely empty. There are clouds of gas and dust. There are stray photons and cosmic rays. Over time, these will erode the spacecraft, very slowly, a molecule at a time. The paint will fade, if paint means anything in such a place. The metal will pit. The golden record, protected by its aluminum cover, will likely survive longer than any of us would intuitively expect. Some estimates suggest it could remain readable for at least 1 billion years, perhaps longer. A message from us, traveling outward, long after the civilization that sent it has been forgotten by the universe that produced it. Think about that. 1 billion years. That is longer than multicellular life has existed on Earth. Longer than the continents have had their current shape. Longer than almost any human concept can meaningfully describe. And yet, if nothing intervenes, our little golden record will still be out there, still turning slowly as the spacecraft tumbles, still carrying the sound of a heartbeat and a song and a greeting from a species that may have long since transformed into something we cannot imagine. During that 1 billion years, the galaxy itself will change. The Milky Way will continue to rotate, carrying its spiral arms through their slow dance. The Andromeda Galaxy, which is currently approaching us at great speed, will eventually collide with our own in about 4.5 billion years, merging the two into a single, larger galaxy. Voyager may or may not still exist by then. It may have been swept into a different orbit by the gravitational upheavals of that merger. It may have been captured by a passing star. It may simply still be drifting, indifferent,
in whatever region of the merged galaxy it happens to find itself. The Sun, by then, will be in its final phase of life. Our star will have swollen into a red giant, engulfing Mercury, engulfing Venus, perhaps engulfing the Earth itself. The inner solar system will be unrecognizable.
And yet, Voyager, launched from that same solar system when it was still young and calm, will still be moving outward in some direction, at whatever speed the gravitational interactions of billions of years have left it with. A small piece of the original system, preserved, continuing. There is a dignity in that kind of persistence. A small, stubborn dignity that we, as beings of short lives and quick attentions, can barely even recognize. But it is there, a machine we built, continuing, long after we are gone. Think about that. 1 billion years. That is longer than multicellular life has existed on Earth. Longer than the continents have had their current shape. Longer than almost any human concept can meaningfully describe. And yet, if nothing intervenes, our little golden record will still be out there, still turning slowly as the spacecraft tumbles, still carrying the sound of a heartbeat and a song, and a greeting from a species that may have long since transformed into something we cannot imagine. It is a strange kind of immortality. Not the immortality of memory, not the immortality of lineage, the immortality of a single, quiet object, moving forever through space, carrying a moment of our attention, a moment of our hope, a moment of our willingness to reach outward just to see. When you go to sleep tonight, Voyager 1 will still be moving. It will travel about 1.5 million kilometers while you sleep. That is roughly 4 times the distance from the Earth to the Moon, covered in a single night, by a machine so old that its blueprints are kept in filing cabinets. It will pass through a region of space that has never been described. It will gather a few more measurements of particles and magnetic fields. It will send them home, at the speed of light, to a planet that will still be turning, slowly, through its own orbit. A small blue dot that will receive the signal and quietly log it and add it to the long record of what we know. The signal will arrive in the morning, local time. Someone at the Jet Propulsion Laboratory will check it. They will confirm that Voyager is still there, still flying, still speaking. And then the day will continue, as days do. Somewhere, a child will look up at the sky without knowing the name Voyager. Somewhere, someone will fall in love. Somewhere, a tree will fall, or grow, or simply stand. The small business of being alive on Earth will carry on. And 15 billion miles away, in a silence we have only recently learned to hear, a small machine with our signatures on it will continue its long, quiet drift into the dark. There is a softness, in the end, to this whole story. It is the softness of something that began in human hands and has now slipped gently beyond them. The softness of work that was finished properly and released, with care, into the keeping of the universe. The softness of a thing you built with love, letting go when the time came for it to go. Every machine we have ever made has a short life by cosmic standards. Cars rust, buildings crumble. Even the stones we carve our names on are worn away eventually by wind and rain. And yet, Voyager 1, launched by a civilization that no longer quite remembers the feeling of the 1970s, is moving outward on a trajectory that will carry it across spans of time that dwarf our entire written history. Its existence, in that sense, is a kind of act of faith in the future. A bet that the future will be there, and that something, somewhere, might find it, or at least remember that it is out there, still flying. The engineers who built it are mostly retired now. Some have passed away. Their names are stored,
along with their signatures, on a small aluminum plate attached to the side of the spacecraft. A quiet gesture, a way of saying, "We were here, we did this, and now this thing we made is going on without us."
There is a woman named Suzanne Dodd, who has served as project manager for the Voyager mission for much of the last decade. She came to the project late in its life, when many of the original engineers had already moved on or retired. She speaks about the spacecraft the way one might speak about an aging relative, with a mixture of affection and realism, fully aware of the decline and fully committed to keeping the conversation going for as long as possible. When she describes decisions about which instruments to turn off next, her voice takes on a particular gentleness. She knows that each choice is a small farewell. There are engineers at the laboratory who have spent their entire careers working on the Voyagers. 30 years, 35 years, 40 years. They started when the spacecraft were young, when the outer planets were still largely unexplored, when the mission was still a source of dramatic new images. They have watched the mission transform, gradually, from a visual spectacle into something quieter, more patient, more philosophical. They have stayed. Many of them have declined other opportunities in order to keep listening. When they retire, they sometimes come back as volunteers. They sit in on the meetings. They offer their memories of old systems, of fixes that were made decades ago, of reasons for design decisions that are no longer written down anywhere. The institutional memory of Voyager lives, in significant part, inside the minds of people who are now in their 70s and 80s, and who care, quietly, about keeping the mission alive. There is a word for this kind of attention. The word is stewardship. It is the attitude of caring for something not because it belongs to you, but because you have been trusted, for a time, with its keeping. The engineers of Voyager are stewards. They did not build the spacecraft, most of them, but they tend to it now. And when the time comes, they will pass it along, or let it go, with as much grace as the situation permits. If you had been in the control room when Voyager 1 launched on that September evening in 1977, you would have watched a rocket lift off in a column of fire and white smoke, shaking the air for kilometers around. You would have heard the cheers. You would have seen the anxious faces waiting for telemetry. And you would have known, even then, that this was not the kind of mission that ends with the launch. It was the kind of mission that begins with it. A mission that, for the engineers and scientists involved, would become a companion of their entire professional lives. For some of them, Voyager has been there longer than their children, longer than their marriages, longer than almost any other steady presence. There is a kind of relationship there that is difficult to describe. Not love exactly, but something adjacent. The patient attachment one forms to a thing that has been there always, whose well-being one watches carefully, whose quiet transmissions one greets each day with a small nod of recognition. When Voyager finally falls silent, that relationship will end. There will be a last signal, a last set of numbers, a last confirmation. And then the antenna will listen and hear nothing. And the mission will, in some formal sense, be closed. A final report will be written. The project, on paper, will end. But the spacecraft will not end. It will continue, indifferent to our administrative categories, drifting onward at 17 kilometers per second through the wide quiet of interstellar space. And somewhere on Earth, some small group of people will, every so often, look up at the sky and think about it, and know that it is still there, still moving, still carrying its small cargo of our hopes and our curiosity into a future none of us will see. In the meantime, while the signal still comes, we listen. We listen carefully. We treat each transmission as the rare and precious thing it is. The mission is in its final decade of active operation, by most estimates, and each year brings a new choice about which instruments to keep alive and which to let sleep. The decisions are made with something resembling reverence, not because the spacecraft is sacred, but because it is unique. Because there is only one Voyager 1, and when it is gone, we will not have another for a very long time. There is a quiet etiquette that has developed around these choices. When an instrument is turned off, the team usually takes a moment to acknowledge it. Not a formal ceremony, just a brief pause. A recognition that something that has been working faithfully for nearly half a century is being allowed to sleep. The cosmic ray detector, the magnetometer, the plasma wave receiver. Each has its own history, its own engineers who loved it, its own set of measurements it has contributed to the long record. When one of them falls silent, the shape of what we know afterward is forever slightly different. This is how the mission will end, almost certainly. Not with a dramatic failure, not with a sudden crash, but with a slow succession of these small farewells, one after another, each one a little quieter than the last, until eventually there is nothing left to turn off, and the spacecraft simply falls silent for good. The final signal, when it comes, may not even be recognized as the final signal until sometime afterward, when the next expected transmission fails to arrive, and then the one after that, and then the one after that. A silence that deepens into certainty. Until that happens, we have what we have. A few more years of news from the edge. A few more measurements of particle density. A few more readings of the magnetic field. A few more fragments of the interstellar hum, gently arriving on the radio antennas of the Earth, one day at a time. And the hum continues. The plasma density continues to shift. The magnetic fields continue to surprise. Somewhere ahead, perhaps, the wall of the local bubble waits. Somewhere further ahead, other boundaries, other regions, other features of the galaxy that we do not yet have names for. Voyager will not reach most of them. Voyager will reach only the next few kilometers of its long road. But for as long as it keeps speaking, each of those kilometers will be studied, measured, remembered. There is nothing more to say tonight. Only that the sky above your window is larger than it looks. Only that the silence out there is not empty, but filled with a soft, almost musical hum that we did not know existed until we sent something to listen. Only that somewhere in that hum, a small, steady voice is still speaking, carrying our love of knowing with it, carrying the memory of everyone who ever looked up at the stars and wondered. Only that, in the end, the universe has turned out to be a kinder place to listen in than we sometimes believe. Full of quiet structures, full of unexpected thresholds, full of gentle drones at frequencies we did not know to tune to, and full, above all, of the strange and lovely fact that a species as small as ours was able to build a thing that could, for a little while, touch its edges. Consider, as this long evening winds down, the sheer improbability of everything that had to happen for this mission to exist at all. A star had to form in this particular corner of this particular galaxy. A disk of gas and dust had to collapse around it. Rocky planets had to coalesce out of that disk. One of them had to sit at just the right distance for liquid water to be possible. Life had to emerge. Life had to survive through countless mass extinctions,
through ice ages, through asteroid strikes, through volcanic upheavals that darkened the sky for years at a time. Life had to eventually produce creatures complex enough to wonder about where they came from.
Those creatures had to develop language, then writing, then mathematics, then physics, then engineering. They had to build a civilization stable enough to fund long-duration space missions. They had to choose, among all the things they could have done with their brief time on Earth, to reach outward. All of that had to happen, and it did. And because it did, a small machine is now 15 billion miles away, sending back the hum of the galaxy on a signal thinner than a breath. There is no other word for that except the word grace. Not in a religious sense necessarily, but in the older sense, a quality of unearned fortune, a gift that arrived without being demanded. The fact that we exist at all, and that we were able to build this thing, and that the thing is still speaking, and that we are still listening, all of it, grace. Let yourself feel that, if you can, as you drift toward sleep. Feel the gentle improbability of it. Feel the long, patient chain of coincidences that led to this moment, to this night, to this quiet hour in which you are listening to the story of a small machine very far away. Feel how ordinary it is in some sense, and how miraculous it is in another. Feel how, just by being alive and curious and awake, you are already part of the same long reach outward that sent the spacecraft in the first place. The Voyagers were launched in a world that no longer quite exists. The Cold War shaped the political backdrop. Disco was on the radio. The first personal computers were just beginning to appear. The people who built the spacecraft dressed in bell-bottoms and wide collars. They read physical newspapers. They sent messages on typewriters. They carried slide rules in their pockets, some of them still out of habit. And yet, with those tools, with that culture, with those instruments, they built something that is now further from home than any object has ever been. Every generation, in its own time, builds things that seem unlikely to their descendants. Future generations will look back at us, as we sometimes look back at the 70s, and marvel at what we accomplished with what we had. They will marvel, perhaps, at Voyager specifically, as a monument to a particular era of human optimism. A period when we still believed, with almost childlike confidence, that it was worth sending small machines into the dark, just to know, just to listen, just to see what was out there. The belief has not entirely gone. It lives on in the quiet rooms where the data is still received. It lives on in the instruments that are still turned on, patiently, each year. It lives on in the slow calculations of future trajectories, the careful accounting of power reserves, the long meetings about when, exactly, to say goodbye. The belief has become gentler, perhaps, more aware of its own limits. But it is still there, and it is worth, on a night like this, letting yourself share in it for a while. The belief that sending something outward is worth doing. The belief that listening is worth doing. The belief that even a very small thing, a voice less loud than a refrigerator bulb, can carry news from farther away than any human has ever been. Voyager 1 is the embodiment of that belief. A small box of components, built by a few hundred people, launched on a chemical rocket, carried by gravity through 4 planetary encounters, slingshot finally into the deep, now drifting past the boundary of everything we thought we knew, still speaking. Still speaking. And somewhere in that speaking is a small piece of each of us. Not literally, of course. We did not send a piece of ourselves into the spacecraft,
but figuratively, yes. Every person who has ever looked up at the sky and wondered what was out there has, in some small way, contributed to the momentum that carried Voyager off the launch pad. Every teacher who explained the planets,
Every parent who pointed out a constellation, every child who asked a question that had no easy answer. The Voyager mission, like every great project, rests on a long, invisible pyramid of ordinary human curiosity. And that curiosity, in some real sense, is still flying out there too. When you close your eyes tonight, imagine, if you like, that you can feel the thin thread of that signal arriving at the Earth. It is arriving right now from 15 billion miles away, carrying a few kilobytes of news. It is arriving at an antenna in California, or Spain, or Australia, at the edge of a continent, at the edge of the wide night. It is being received, it is being logged, it is being added to the long record of what we know. And then, somewhere out there, where the signal began, the spacecraft continues on, silent now until the next transmission, still moving, still the same small machine we launched 48 years ago, still carrying with it a small golden record, still carrying on a small aluminum plate a list of names, still carrying, more than anything else, the weight of our hope that reaching outward, even in a small way, even for a little while, was worth doing. Rest now. The spacecraft is still flying. It will fly for a long, long time.